So last time we did an example problem using the char function and the empty string function. This time we're going to do this same example problem. We're going to solve for these two columns, but this time we'll be using the fprintf function to print out this table instead of using the char and empty string function. So let's jump into it. Same as last time, we're given column 1 and column 4, so we're given speed and time, and we want to find the distance and then deceleration. So here we have 9 equally spaced speeds from 10 through 100, and it's a column vector. Keep in mind your column vectors and your row vectors. Also, here we have times, 9 times. They're not equally spaced, I believe. Yeah, they're not equally spaced. And then it's also a column vector. So for part A of the problem, they want us to calculate columns 2 and 3. So these two columns, and make a matrix A such that A is assigned a matrix that contains 4 vectors S, X, A, and T. Where S is speed, X is the distance, A is deceleration, and T is time. So let's find acceleration first. So acceleration is equal to, or is assigned, speed dot divided by time, because acceleration is equal to delta V over delta T. And then we have to find the distance, or delta X, which is, from kinematics we know, is 1/2 at squared t squared, and that should work. We'll just run this code real quick to compare our answers. Okay. Run. Okay. So we see that our answers for deceleration is what we want it to be, and then same with distance, 14 point. Yeah, okay. So our answers are consistent. So we can just go ahead and make a matrix A that contains these 4 vectors S, X, A, and T. Since we already called them those, so we don't have to worry about changing our variables and whatnot. Okay, so now moving on to part B of the problem. We have to use the fprintf function to print the table. So since in this case we'll be using 4 fprintf functions, so we'll be using it 4 times. fprintf, fprintf, and fprintf, and fprintf. So we'll be using the function 4 times in total, and we'll be printing the table. So I'm just going to copy it for the first 3 fprintfs. So I'm just going to copy this first 3 lines. So I'm not going to retype that. So I'll just copy and paste it here. There's one thing that you also have to keep in mind when using the fprintf function is that it will print the line, but it will not go to the next line until you tell it to go to the next line. So you have to do that. Paste. Okay, so for it to tell MATLAB to go to the next line, you put \n, inside the quotations, single quotations, \n. So all it says is after you print this line, go to the next line, and you have to do it for all of them. Okay, so now after these single quotes, you put a comma, and then you put basically a big matrix of what you want to print. Here we want to print speed first, and then distance, then deceleration, and time. So we want S, X, A, and T. We want to print it in this order. I've mentioned this before, that when you're using fprintf, you want to use column vectors because it's easier that way. So since these are column vectors, always make everything that goes in here column vectors, and then use a prime here. So these are already column vectors because S and T were column vectors. So S, X, A, and T, they're already all column vectors. Then you use a prime here. It's just a thing you should remember. If you don't, it doesn't take that long to figure out what you did wrong, but that's okay. Once you've done that, you have to put a format to print your like values. So here you want to print this first column in 2 decimal places. So what you would do is you would say percent, I don't know, 6.2f for printing numbers. Then you would say percent, you want 4 decimal places here, so I would say maybe percent 8.4f. More emphasis on the last, what comes after the decimal point right here, because that's what signifies the number of decimal places you will be going up to. So keep an eye out for that. And then you have percent 8.4f again. So if I run this, it should give us the table we want. Yeah. So okay, wait. Okay, is this the table we wanted? Okay, yeah, it is the table we wanted. So it's pretty straightforward. Using fprintf function, it makes your life much easier. It's better than the char function. So once again, for the first line, when you use fprintf function, it's just saying whatever's in here inside these quotations, you print that. Except for this \n, it's something in MATLAB that's coded to say go to the next line. So it will print this, it will go to the next line, print this, go to the next line, print this, it will go to the next line after that. And they will keep doing that until you print the table. Once again, keep in mind that everything that goes in here is a column vector, and then you put a prime at the end. Now remember, you don't have to do this. You could have just put in an A right here. You could have just simply done A prime, and that should have worked. Let's see. Oh, that doesn't work. Oh, because I didn't run this part. Okay, yeah. So you could have just put an A there, and it would have been just fine because it will just take the first, second, third, and fourth column of it. So it's optional. A lot of times you will just see people writing an A, declaring a variable A here, assigning it everything, and just putting that there because it's neater that way. But it's up to you. I like writing everything out so I know what I'm printing, where I'm printing it. But that's about it for the fprintf function. Thank you for watching. If you have any questions, let me know.